Hello everyone, this is Joe Neville, how's it going? So in this video we are going to be taking a deep dive into IPv6's address allocation methods, and I'm going to be demonstrating this using Aruba's AOS-CX network operating system. One of the many differences between V6 and V4 is that V6 offers more ways for clients to generate their own globally routable addresses. So this is a big positive, but also there is some complexity in there, so it's worth getting to grips with these details. Now here's the network that I've set up. The main device under test is going to be the 8320 that I've got here, and I'm running Aruba AOS-CX 10.350, which was the latest when I was recording this. Up here I have a server LAN which is running my DHCPv6 server function and DNS, that's Windows Server 2019. Now, the 8320 is positioned as a core or an aggregation layer device. And to play the access layer role, I've installed an Aruba 3810 here. That is a layer 3 device, but in this network, it's just going to be performing a layer 2 function and power over Ethernet. And I've connected into that switch an Aruba access point, so a UAP 303HR. To provide my WLAN. Now the way that this works is that on the CX device I've configured 5 VLANs, here they are detailed here, and the 8320 and the 3810 are connected with a trunk, and then the 3810 to the UAP is connected via a trunk that transports those VLANs. And if you look here, what I've done is the first one is just for management, the next 4 are the interesting ones. So VLAN 1001, for example, with this prefix here, 2001 DB8A 1001/64, I've set the configuration up on the CX device for SLAAC. So the clients will generate their own globally routable addresses when they connect to this VLAN. Then looking at the next one, 1002, I've set the CX configuration up for DHCPv6 Stateful. Next one, Stateless. And then the final one, I thought I would combine everything so we have SLAAC and DHCPv6 Stateful turned on this VLAN. And then to emulate a more modern approach to networking that you'll see in today's campus LANs, I've tied those VLANs to 4 different SSIDs here. So we've got this V6net SLAAC tied to the VLAN 1001, Stateful to 1002, Stateless to 1003, and then this V6net all on to 1004. So what I can do with my client here, which is my MacBook, I'm going to connect to each one of the SSIDs in turn. So run some Wireshark captures and see what addresses the client has generated, but also log into the 8320 and have a look at the configuration. And we'll move on through the different SSIDs, checking the details as we go. There's a lot of detail to cover in here, probably too much for a single video. So what I've done, which you may find of use if you want to delve into this further, is before I make this video, I wrote all of this up on a document that I've put up on GitHub. So everything that I cover here, all of the network design, as you can see here, it's the network, all of the configurations, and a detailed run through of each one of the allocation methods. So if you're not up to speed with SLAAC or DHCPv6 Stateful versus Stateless, I've written all of that up to try to help any kind of beginners here, and then you can see the configurations with notes, and I put the native CLI in there as well, so you can copy and paste that if you should so wish. And I've also got a packet capture, so there's a lot of detail in there for everything that I'm going to cover in this video. I will put a link to that in the description. That's enough intro. Let's have a look at our first address allocation method, which is SLAAC. Let's dive into the demo then. So on my screen now, I have Wireshark in the top half. so that we can see packets coming in from the CX device, and I filtered on DHCPv6 and ICMPv6 type 134, which is a router advertisement, so that we're just seeing the packets that we're interested in for address allocation. And on the bottom half of my screen I have a terminal which I'll use to show the IF config of my Mac, so we can see what addresses my Mac has picked up. But also we'll SSH onto the 8320 so we can see the configuration that's creating the different address allocations. Plus, we'll do some show commands so we can try to tie this all together. Okay, so let's start Wireshark. So now we're capturing, and I'll turn on my Wi-Fi over here. And the first network that we connect to will be the V6net SLAAC. Okay, so straight away we've got an RA, and I'll stop the capture there because that's all we need. Bearing in mind that with SLAAC there's no DHCPv6, you don't need a DHCPv6 server. Here's the interesting part then, so it's ICMPv6, yes, router advertisement 134, okay, and in here we are looking for the prefix, so the prefix is at the bottom here. And under the prefix, we have some important information such as the autonomous flag. Actually, it's turned on there, so that is set. You can see the 1 there. And that's what's indicating to the client to use this prefix here as the first half of its address. So bearing in mind that an IPv6 address is 128 bits, the first half is this, and the second half, the client generates itself to create a globally routable address. So let's jump over to my Mac here on the terminal. We're doing ifconfig en0. And we can see the addresses. Now there's 2 addresses that have been created, and as you can see 2001 DB8A 1001, so that's the first half of the address there, and then this, the following 64 bits for the second half, that is created by the client. Now having the 2 addresses is correct. We have MacOS calls them, one of them secured and one of them's temporary. So the secured has a longer lifetime, and the temporary, I think for most OSs it has a lifetime of 24 hours, and this forms the source address for any traffic generated by the client. So the secured address is something that you would put into DNS, for example, whereas the temporary only lasts for a short amount of time and is to make tracking of clients more difficult for any rogue agents out there. So with SLAAC, we've got the 2 addresses created off of the prefix sent by the 8320, and it's the A flag set that indicates to the client to use that prefix. Okay, great. So let us SSH into the 8320. Okay, here's the configuration then for the layer 3 interface. This is the important stuff for us. I've given it a description of SLAAC, and I put an IP address on here, so 2001 DB8A 1001:1/64. So that's where the 8320 is taking the prefix to add into its RA here. But I should say that by default, CX devices suppress their RAs, so they won't send. An RA is a really powerful thing on a network. As you can see, clients, so Windows or macOS, they actually generate their addresses as soon as they hear from a V6 gateway. If they hear an RA, they generate these addresses. So with CX, Aruba is erring on the side of caution in the configuration, and you actively have to allow RAs. Now the way to do that for this setup, I'll show you in the configuration, because there's multiple approaches. If we go in here and I do, so it'll be no IPv6 ND suppress RA. That's the command to allow an RA. But it's a bit more complicated for our setup, and that's because we're adding extra options into our array. If you think about clients in a modern network and comparing this to, say, DHCPv6, clients need more than just an address to operate in modern networks. So they'll need a DNS server, and they may need a DNS search list, so a suffix to add to their DNS searches so they can have fully qualified searches. Okay, so that information was not in the original spec of SLAAC, but SLAAC was extended by RFC, so it's 6106, and then that was replaced by 8106 to allow us to include in the array not just the prefix for the address generation, but also a recursive DNS server and a DNS search list. So it's RDNSS and DNSSL, and you can see here that I have configured those on here. So this is how we configure. This is the search list. So I've called it actium.home is the suffix for my domain. And I have a DNS server, which is 2001 DB8850::10. And if we look in the Wireshark up here, you can actually see those options are included in the array. So there's the recursive server, ::10, yes, and there's actium.home, good. So that provides the additional information for our clients. But there's a slightly tricky thing here with the way that you then have to allow the array with CX, because if you just put the default of no IPv6 ND suppress RA, it will not include those two options. So you have to allow those options as well. And what you can do in the config, it shows it as two separate commands, but you can enter it. I'll show you that now. You can enter it as a single line. So it's suppress RA. Okay, if we do a question mark there, you can see the different options. There's MTU as well, which I haven't included. But we can put that as a single line rather than having to put the two commands in separately. So if I enter that, that's not going to do anything here. But if you look at it, it will show that in the configuration as two separate commands. Okay, so it can be entered as a single command, it will show up as two. Fine. And what that's doing then is not only allowing arrays, but also allowing arrays with these additional options. That's it for the SLAAC CX interface then. If I come out of here, let's have a look at some show commands. Do show IPv6 ND interface VLAN 1001, and this gives us a breakdown. So there's quite a lot here. Okay, you can see the admin state, the IP address, when we last sent an array, when we're next going to send it. If you want to speed that up in your lab, you can do. You can tweak those timers. This is where we can tie up what we're seeing in the Wireshark with the show command. So you've got here the send managed address configuration flag false. That's for DHCPv6. You'll see that up here in the flags. So if I expand that, you'll see is not set. So that M flag there is this setting on here. The other setting, which is used within DHCPv6 Stateless, which is also set to false, is the other flag, and the other flag in the packet of Wireshark shows up here, so that's not set. So these two tie together. This is interesting here. The suppress RA is false. Good, we're sending the RAs. And here's another useful command. If we up arrow there, so it's show IPv6 ND interface VLAN 1001. If we put in prefix, you can see this part here tied to the different prefixes, because you could have multiple prefixes that are sent in the array. We've just got one, and this information ties in with what you'll see lower down underneath the prefix. So this information here, you've got your valid lifetime, preferred lifetime, etc, etc. You can see those values tie up. You've got onlink, which is this flag here, which is set, and we've got the A flag, which is set. So that's how you can check that on CX. So it's show IPv6 ND interface VLAN 1001 prefix. Let's come off of this device then. Let's have a look at a few final commands on macOS then, which are useful. So to see it's all very fine and good seeing the DNS server and the search list coming in on the Wireshark, but how do we know that our Mac is using that information? We can do, so it's scutil --DNS, and you'll see in there, so you've got the resolver there, you've got the search domain, you've got multiple. If I scroll up, you can see that there's multiple in here. Resolver 1 is the one that we're using here, so that's actium.home, good, and there's our name server, the ::10. That was SLAAC. Now on to DHCPv6 Stateful. Firstly, I've logged into my Windows server so we can have a look at the DHCPv6 settings and the scope options. Here's the scope I've set up for Stateful. I'll show you the properties. So it's 2001 DB8 A 1002. Okay, that, and an interesting thing here is the scope options. So let's open those up. And you can see here, so it's option 23, that's the recursive name server. And I've got that as 2001 DB8 A50::10, which is this device, and I've got a domain search list of actium.home. Now the thing is, I thought it would be a bit boring to just keep showing you the same thing, so I'm going to change the search list here. Let's remove that, and I'll call it Actium2. We'll add that in to prove that we're getting different options down to our client. Let's connect to the Stateful SSID then. I'll turn on my Wi-Fi. We should automatically connect, which we have. Okay, so there's our messages. I'll stop the capture. I've colorized these so that they're more noticeable. So we've got our RA there, we've got a solicit, advertise, request, and a reply. So let's look at the RA first. Right, so this is expanded. Here's the RA. We have the most important part here for DHCPv6 Stateful, the managed flag. So that is set to on. You'll notice that the other flag, the O flag, is off, but that's ignored here. The managed flag is all that we need to be able to get an address, and the other information, those other options 23, 24 that I set. If we scroll down, we see the prefix. So there's the prefix there, and you'll also see with the prefix that on-link flag, the L flag is set, but the autonomous flag is not set, so the client should not generate its own address from the advertised prefix. And there's the advertised prefix. So let's dive into those DHCPv6 messages then. So it's the 4-message exchange. We have the solicit, where the client is trying to find the DHCPv6 server. It's on a different subnet, so our 8320 will be forwarding that on using the helper address. And so here's the solicit, and also of interest we have the option request. So the client, so macOS, is actually asking for the recursive name server and the search list, so 23 and 24, and also asking for an IA for a non-temporary address. Okay, then we have the advertise from our DHCPv6 server. So we'll scroll up for that. You can see the server identifier, and this has the address in it. There's the address, and the recursive name server, there you are, 2001 DB8 A50::10, and then that search list there, and there's the new search list that I set, Actium2.home. Then we have a request, and we also, so this is from the MacOS client, and then we have a reply. The reason for that is if you have multiple DHCPv6 servers, the client chooses one to then have confirmation from. So you get the solicit, you get the advertiser, which has got all of the information that the client needs, it seems, in it, but then the client says, okay, so of the multiple, if there were DHCPv6 servers, it picks one with the request, and then that server will respond with the information. So you see it responding with the address, the server, and the search list. Let's have a look on macOS then. So ifconfig in 0, and there we can see that is the same 2001 DB88 1002, and it ends with 8043. That matches this address. And you can also see from SLAAC we had a secured and a temporary address. With DHCPv6, macOS calls it dynamic, and there's only a single address. Let's have a look at the DNS information there. So you can see the search domain Actium2, and there's the name server. So that's all good on our client. There's an additional command that we can use actually, which is ipconfig get v6. Can I tab that? No. Packet en0. Okay, so this actually shows us the DHCP reply then, so that final message that came in. You can query macOS to say what did the DHCPv6 server send to us. So here you can see the address, you can see the server ID, client ID, good. There's our DNS server and our domain list. Okay, so next up, let us SSH up to the 8320 and have a look at that config. Let's have a look at the configuration on the interface then. Here we have the address. We'll skip this line, talk about that in a moment. So this is the managed flag. That's the M flag being set in the RA, and we're allowing the RA here. See, it's the shorter version from the SLAAC version that had the no suppress of the DNS information as well. So it's just suppress -RA. We have the helper address there. So because we're on a different subnet to the DHCPv6 server, we will forward on the DHCPv6 solicits to this address, and it's unicast. Now there's another command that you also have. So this is important actually. I'll show you the full configuration. So this one here, this DHCPv6 -relay, that needs to be turned on. On CX, that's not on by default, so that's an easy one to miss with V6. With DHCPv4, that is on by default, but not for V6. So make sure to include that one. We'll go back to that interface then. And then the final thing that I wanted to mention is this rather ungainly command here. This one is actually to turn off the A flag. So this line here is actually very important if you want the clients to just use a DHCPv6 address, because the A flag on a /64 prefix is on by default with CX, and macOS and other clients will be looking for that A flag. As soon as they see that on a /64, they'll start generating their two addresses, the secure and the temporary, on macOS. And what this is actually doing then is, this is the default. So if will go into the configuration so you can see this. So IPv6 ND, and then we have the option for the prefix there. Right, so you can set, if you've got multiple prefixes, you can set the specific prefix. I've gone for the default option, so everything or every prefix on this interface. So I've gone default, and then you have to put in the valid type. Now this, I've just put in infinite. Then we've got preferred. I've put in infinite again. And then finally, we get down to the no auto config. So that's right down here. So we'll go no auto config. And then that actually shows in the configuration as this. So that is to make sure that this is turned off. So if you miss that one, you're going to have more addresses on your clients than maybe you bargained for. Come out of there. We'll do a show IPv6 ND. What is it? Interface VLAN 2001 to finish up. There we can see, okay, we're up. We've got, that's our address, sure. We've got our RA, and this matches up. So the M flag is on and the O flag is off, and we're not suppressing RAs. That's it for stateful. Now let's move on to DHCPv6 Stateless. Here I am back on my DHCPv6 server. So the thing is with stateless, the DHCP server doesn't provide the address, but the scopes are defined by the address. That's one of the key components. The way that we set stateless, because we don't offer an address, is here with the server options. So I go to server options, and these are the ones that sit outside. They're like the global for the server, so they sit outside of the scope, and these are the ones that will be returned without an address. As you can see, it's option 23 and 24 that I'm offering again from my server, and I think I'll do what I did last time by changing the properties so you're not just watching me do the same thing each time. So let's remove that one, and we'll call it Actium 3. Add that into the search list, apply, OK. Now we'll hop back over to my client to log into the relevant SSID. I've got my Wireshark running here. We'll turn on my Wi-Fi connection again. I already set up my Mac to join the SSID that we require. This time it is the stateless one. And we've already got the packets that we require. So I'll stop the capture. So we've got an RA. We have, so for stateless, we have a different DHCPv6 message from our client. And this is the one, the information request is used to just request the other information from the server, not an address. And this is just a two-message exchange. So we've got an information request and a reply. Let's go through those then. So starting with the RA, here we have the RA. We have, okay, so it's telling us there, other configuration. The M flag is not set, but the O flag is set. Good. So we'll go down, you can see the prefix there is the 2001 DB8A 1003, okay, and then the flags for that prefix. Now this is of interest, so we've got the onlink flag is set and the A flag is set, so the autonomous address configuration, because with stateless we don't get our address from the DHCPv6 server, we get it from the prefix that's sent by our local first hop router. Moving down then to the DHCPv6 packets, the information request. Here it is. So we've got client identifier. We've got the requested option codes, the recursive DNS server and the search list again. Oh, and that's it actually. That's the packet. I thought there was more. Okay, and here's the reply. So this will be forwarded on again, I should say. This is because the DHCPv6 server is on a different subnet. This will be forwarded on by our CX device, and it will hit our Windows server, and then we'll have this reply come back, and that reply will have the relevant information that we need. There we are. There's our server again, and the search list actium3.home, which I have just set. Okay, so on the terminal of my Mac then, let's go through the commands. ifconfig en0, and there you can see, because this is like SLAAC for the address assignment, we've got our two addresses. We've got our secured and our temporary. both in the offered prefix 2001 DB8A 1003. Let's have a look at that DNS information then. DNS, okay. You can see actium3.home and our name server. Finally, we can use that ipconfig command as well. Let's see what that says. EN0. And there you can say, okay, so it's the information that's reflected in our other captures. All looks good. So we will log on to the device then and check the configuration. We have /64, of course. We have no suppress the RA. And again, it's just this command that's required because we're not using the RFC 8106 information. Of course, we're using DHCPv6 for that other information. We have the other flag set there with that command, IPv6 NDRA other config flag. Then, of course, we have the helper address. We also need, and we mustn't forget, the DHCPv6 relay for this type of network. Let's look at that other command that we've been checking then, the IPv6 ND interface VLAN 1003. And okay, we've got the address, fine. We're sending RAs, and there you can see M flag is false, but other flag is true. Okay, so that ties up, and we're not suppressing our RAs. Good. That's it for our third option then. Now for our final SSID, this is where we combine SLAAC and DHCPv6 Stateful, which I've called V6Net All On. One last SSID, I'll turn on my Wi-Fi, and there we've connected to All On. Okay, stop the capture. So we've got our RA and our 4-message exchange. Now in this case, so this is where we have DHCPv6 and SLAAC active at the same time. So we have the managed flag. That set. We also have the A flag set against our prefix. So 2001 DB8A 1004/64. And if we go through, we've got the solicit there asking for the non-temporary address, even though we've got the A flag set, so the client can generate 2 addresses. We have the advertise, the request and reply. So we'll jump to the reply, and in there you can see the IP address that's offered, and we've got the same information for the DNS server and the search list. Looking at our client then, I have config EN0. Now here you can see, so we have the 2 that are generated, so the secured and the temporary, which are generated via SLAAC, and then we've got the dynamic, which is the DHCPv6. So there you can see there's actually 4 addresses against this interface at this present time. Checking the DNS, as you'd expect, actium.home and the DNS server IP address. And again, we've got the address, we've got the server, and we've got the search list there. Looking at the configuration, I think you can see how easy it might be to mistake this configuration here for DHCPv6 only, whereas in reality it's actually DHCPv6 and SLAAC at the same time. So we have our address, we've turned the M flag on, we've allowed RAs, and we've got our helper address in there. But what are we missing? If I can compare that against our DHCPv6 Stateful, of course, we haven't included this command, so the default or the prefix specific command to turn off the A flag. So if you miss this command, you could end up with your clients having more addresses than are necessary. So I think that's one to look out for. Let's have a final look then at our interface 1004, where you can see we've got the address there, we've got the M flag on, and we're sending the RA. Now if we look at that command though, there's an additional keyword that we can use, prefix. You can see also the autonomous flag is set, and that ties in with what we're seeing up here, and that creates this situation where you have 4 addresses against an interface where you may not require them. Okay, so a lot of information in this video. I am aware of that. I've written all of this up in a document which is up on GitHub. This is the main repo, CX IPv6 address options, under my username. And if you click on this link here for the markdown, you've got all of this information written up, so you can see the different VLANs there. That's the network that we've been looking at. I've got notes and configlets, and I've got captures as well. So I've broken all of that down. But that's all for this video. Please give it a like, dislike, subscribe to the channel, all of those good things. Feel free to leave a comment. The document, one of the reasons why I've included the document on GitHub is because I can then expand upon it and keep it relevant and up to date. All that's left for me to say now is thank you very much for watching. My name is Joe Neville, and goodbye.